Good morning. Like Dave, I'm really fortunate to be able to work in an industry that I'm passionate about. Within motorsports, it's all about innovation. It's all about making changes and coming up with the next best thing. Looking for race teams, race engineers, designers are looking for tenths of a second, thousandths of a second. Again, you know, we talked about trying to get lightweight. Well, the accumulation of the time that can be found with all these new technologies that are experimenting with within motorsports, personally I find fascinating, and it also, you know, is very adrenaline filled. Top 10 things that we have in our cars today that, you know, that came from motorsports or were developed through motorsports. Current transmission technologies, primarily in performance cars now, the DSG or twin gear shift transmissions, which are basically two transmissions built in one. One gear is already on deck, ready to go into the next. The shifting is absolutely seamless and happens within a very few milliseconds. Sequential transmissions, twin clutches, electronically controlled transmissions and clutches. A lot of that was developed for manual transmissions within motorsports. Again, looking for those milliseconds, looking for the way to speed processes up. Simple time savers, push button start is a good example. Go into suspension components, independent suspensions, differential technologies, things like that are all being developed at a very rapid rate within motorsports that we're finding in our road cars. Tire construction. Michelin technology that's developed for motorsports has a direct transfer into cars that we drive. An example is the technology that's been developed for the new Pilot Sport tires that are on the Corvettes. There's also twin compounds, so they have a harder rubber compound on one side of the tire, a softer rubber compound on the other. Those sorts of innovations that were originally developed and proven within motorsports we're starting to see on the road. Disc brakes, well, almost everything nowadays has disc brakes on it. Disc brakes actually were developed or designed back in the early 1900s, but the reality of the development or the rapid pace of development really didn't start until the 1950s when we started to see them on competition cars. And at that point in time, things like vented rotors and the technology of the friction materials, again, started to develop at a very rapid pace. Induction systems, turbochargers, superchargers, we started to see those in motorsports back in the 1930s. Obviously nowadays, we see them everywhere. It's a very efficient way to make a lot of power with a very small displacement power plant. Engines themselves, cylinder head technologies, the materials used within the engines, you know, nowadays a good example is the Chevrolet LS engine, which is aluminum block, aluminum cylinder heads. The engine's approximately 30% lighter than a small block Chevrolet, cast iron Chevrolet that was used just a few years ago. It also makes considerably more power. Aerodynamics. Aerodynamics that were developed in racing we see on our cars every day. Chin spoilers, rear wings, rear lips, all these things we think, okay, they have, you know, they make the car look more aggressive and they make it give you the feeling that you're in your own little sports car environment. But the truth is they create less lift, less drag, and in a lot of cases nowadays are creating downforce, which in turn makes the car more efficient, gets better gas mileage because of some of these aerodynamic aids. Simple safety items, rear view mirror, first appeared on race cars back in the early 1900s. Safety cells, everything we drive nowadays has basically a roll cage. And a lot of the structural integrity that's built into the cars, a lot of that development has transferred over from the motorsports industry. Lubricants are obviously an important thing, and it's the lifeblood of any engine. Within motorsports, an example, the mobile engineers that travel with the Formula One circuit are developing new technologies and fine-tuning what they currently are producing and putting in these engines every 2 weeks. So the development cycle, when you get into motorsports, is really not months and years, it's hours and days. Simple things like efficiency in lubrication, dealing with friction losses. Within the transmissions, you're trying to eliminate as much of the driveline losses as absolutely possible, and lubricants play a big part of that. Wheel bearings, CV joints, the greases that are developed now are designed to minimize rolling resistance. Hydraulic systems, a lot of the current F1 cars are transmissions are all hydraulically operated, and they operate at up to 200 bar and about 112 or 212 degrees centigrade. So the operating temperature is extremely high. You have to develop lubricants and oils that can operate in that sort of environment. Next is the engines. They're no longer called an engine.
For Mercedes-Benz, Formula One is the perfect laboratory for developing state-of-the-art technology.
Power units, no longer an engine. In motorsports, we're starting to see at the top rungs of motorsports, we're seeing these types of technologies. Current Formula One power unit, 1.6 liters. My Mini Cooper is 1.6 liters and makes nowhere near 900 horsepower. That's what these little engines are making with the addition of the electric power that's being stored in the batteries. Not only that is the amount of instant torque from the electric engines, or electric motors, I'm sorry, along with the electric motor that's spinning up the turbocharger, it virtually, when the driver hits the throttle, you basically have close to 900 horsepower on tap all the time. It's, you know, there is no linear curve. It basically goes up and then goes flat. It's really amazing stuff. These are a couple typical world endurance cars right here. Current thinking is with these cars, they're mid-rear engine cars. They also are using hybrid type technologies. Again, every time they put the brakes on, they're trying to make things more efficient. They're trying to store that energy. The Toyota, which is the blue and white car, that particular car uses a supercapacitor to store its energy. The Audi is also a hybrid vehicle. It's using batteries to store its energy. The difference between the two, the Toyota being rear-driven only, the Audi has two electric motors that drive the front wheels. So coming off of a corner, it engages the electric engines and gives the car additional drive coming off the corner. Again, innovation is all about motorsports, trying to find a better way to do something. That's LMP1 GTR that's being built by Nissan. I don't know if you could tell from the photos, but the car does look a little different. It's got a really long nose. The reason for that is that car is front engine, front wheel drive, also a hybrid, uses a KERS hybrid system. It is the hybrid system not only delivers power to the front wheels, additional power, electric power to the front wheels, it also has a shaft and drives the rear wheels. One of the big differences of this car compared to the mid-engine, rear-engine cars is the ability to achieve a new theory in the balance of the car. They're not having to deal with aerodynamic aids to get more weight on the front of the car. This particular car has 75% of the weight on the front wheels. Therefore, drive coming out of the corner is be able to put the traction down and be able to get good drive off the corners with the assistance of the electrical power driving, giving the assistance of the rear wheels. Aerodynamics. The big thing on these cars, on this new design of the Nissan, is it's aerodynamically really efficient. Very low drag. It has 2 tunnels that run through the car, so they're using the air that's going through the car to create downforce, which the way it's designed, it creates very little drag. Then they're maximizing the use of air that goes underneath the car, once again, to create downforce. This particular shot is the latest version of the Delta Wing. You see it's a closed cockpit car, which is the new regulations for the LMP cars now requires. What's interesting is both of the Nissan LMP1 and the Delta Wing are built in California. Well, actually, that's not quite true. This particular Delta Wing now is built in Georgia, but the original concept was built at All-American Racing, Dan Gurney's facility out in Southern California. Half the weight obviously produces much less, it takes much less power to move it through the air. Much less drag. As you can see, it looks like an airplane without wings. Has 1/3 the frontal area of its competition. And if you notice, it does not have a rear wing like the Toyota or the Audi. Again, to eliminate drag, it creates a tremendous amount of downforce, maximizing the use of the air that's underneath the car. 75%, now just the opposite of the LMP1 GTR, this car uses 75% of its weight over the rear wheels. Again, eliminates wheel spin coming off of a corner, being able to put the power down sooner. Being half the weight, half the engine, or substantially smaller engine size, it gets much better fuel economy. It's much easier on the consumables, tires and brakes, so they can go further between pit stops, have to make fewer tire changes and all. Now these technologies, we're starting to see, these technologies we're starting to see in road cars, or have been in road cars for a while. Simple things like ceramic brakes. Ceramic brake rotors started showing up in Formula One in the 1990s. They're at least half the weight of a conventional iron rotor. Latest supercars from Ferrari, Porsche, McLaren, and Chevrolet are using, composites within the chassis. They're using energy recovery systems like KERS to make massive amounts of power. Electronically controlled or hydraulically controlled transmissions and clutches. Active aerodynamics. And again, going back to a lot of aluminum components, composite components and all that we're seeing in today's road cars. And in closing, I want to say that besides being a lot of fun, motorsports does really drive a lot of technology, not only for your road cars, but for a broad spectrum of things with data acquisition and things like that. So again, thanks for being here. Really enjoyed it.